Okay, now outdoor air and the circulated air with external bypass system. External bypass, ito. Tingnan nyo yung figure, yung psychometric chart. Ito yung schematic diagram ng equipment. Outdoor air and the circulated air bypass with bypass system. So, sabihin, M-O, P-O, nag-bypass sa coil. So, iba yung dito sa loob mismo ng equipment ng CDA, may bypass. Ito yung bypass dito is yung bypass dun sa pins. Hindi lahat yung kasi may contact. Okay? So, dito naman sa outside to, external, tinawag na external bypass. So, sabihin naman kung ilan. Okay? So, this is the diagram, the geometric diagram. Kung ito, 100%, ito hindi. So, yan. Let's say, 1, 2, so 1, 2, mix ng 5, tapos 3, cooling coil, CDA, and 3 to 4, itong 3 to 4, itong 5 saka 4 nag-mix, so dito sa 4. Yung 4, ito na yung supply doon sa room mo. Neglecting fan effect. Okay? So, yan. Diagram. So, pwede siya sa along sa gitna ng 4 kasi nag-mix yung 3 saka 5. Okay? So, in the bypass system, part of the recirculated air is controlled by damper action. In order to make it bypass the conditioned air. This bypass air is used to reheat the air leaving the refrigerating coil to a more suitable temperature for distribution at the gate outlets. So instead na reheat coil, yan ang gamitin mo pag kaya. Pag hindi kaya, so mag-reheat coil ka. This method produces economical performance as compared with system with reheat might be used. Okay? So dito, mag-additional ka lang ng lock. Wala yung reheat. Pero yung picture, kung ito gamitin mo, hindi naman kaya, so mag-reheat ka. So the refrigeration load if UCDA is equal to M sub 2 times M sub 2 minus S sub 3. Or M sub O times H sub 1 minus H sub 3 plus M sub RC, the circulation, plus H sub 5 minus H sub 3. RC. Ito. Ito naman yung return air, circulated RC. Then ito yung bypass. S, yan yata yan. Ayan. As a return. Okay. So the Q sub CDA is also equal to the ventilation load plus the air conditioning load. So Q sub DA is equal to M sub O times H sub 1 minus H sub 5 plus Q sub S plus Q sub L. Well, M sub O is the mass flow rate of outdoor air in kilogram per second. M sub 2 is equal to M sub 3 is mass flow rate of air passing the CDA. M sub BP is the mass flow rate of bypass air. M sub RC is the mass flow rate of the circulated air. So wala dito nilagay na M sub BP. So yan ang symbol niya. M sub BP. Iba nakalagay dito. Sige na. BP nga, capital B and P. Kala ko SR. So yun. Some important points to remember. A, in the bypass system, parts of the recirculated air is controlled by damper action in order to make it bypass the conditioned air or CDA. The warmer bypass air is used to reheat the air leaving the CDA to more convenient temperature for distribution at the green outlets to the conditioned air. Minsan masyado malamig sa labas. Mga ano. So may mga condition na ganyan. Normally, wala, diba? Pero may mga system na minamanipulate. So, nakukuha yan. Mamakuha mo yung desired room design condition. Lalo na kung controlled yung relative humidity saka temperature. B, the circulated air with external bypass is a method that produces more economical performance as compared with system where heat might be required. Letter C, the recirculating part of the air from the conditioned room is more economical than using all outside air because the temperature of the recirculated air is more favorable than that of the outside air. Letter D, the temperature of supplied air to the conditioned room is always lower than the temperature inside in order to maintain the required room temperature and to remove the sensible heat load of the room. E, the moisture content or humidity ratio of air supplied to the conditioned room is always lower than the humidity ratio of the air inside the room inside in order to maintain the required humidity ratio and to remove the latent heat load of the room. F, sensible heat ratio, SR, is the ratio of the sensible heat load and the total heat load of the conditioned room. Okay, kahit wala lang natin important points to remember. Letter G, the use of all outside air with no recirculation as supply air to the conditioned room is uneconomical unless the outside air condition is close to the temperature and humidity ratio to the maintained room condition. H, the moisture picked up from the conditioned room by the circulating air is given by the following equation. M sub B or M sub water, water yan, is equal to M sub A times Ws minus Wr, where M sub B is the moisture removed, kilogram per second. M sub A is equal to mass flow rate of the dry air, kilogram per second. Ws is equal to humidity ratio of supply air, kilogram per kilogram. And Wr is equal to humidity ratio of room air, kilogram per kilogram. And letter I, the sensible heat load of the conditioned air is given by the following equation. U sub S is equal to M sub A times C sub B times T sub S minus T sub R, or 1.02 M sub A times T sub S minus T sub R. And SI units itong 1.02. English units, ginamit pa ito. Okay? Equivalent yan, that is 0.245. Where Qs is a sensible heat load, kilowatt, M sub A is equal to mass flow rate of supply air, kilogram per second. C sub B is equal to specific heat of air, 1.02 kg per kilogram centigrade, Celsius. Sa S na English is mga 0.245. Okay? T sub S is equal to temperature of supply air, centigrade, and T sub R is temperature of room air, Celsius. Okay, Celsius or centigrade. J, the lower the temperature of air supplying the conditioned room, the less quantity of air is required to circulate or supply. Okay, the minimum temperature of the supply air is dependent on the system arrangement, the necessity to avoid drops in cold regions, the ceiling height, and the throw required. And the amount of air circulated to the conditioned room must be adequate to handle the cooling load as the air warms up to room temperature from its supply temperature. So example number 1. So example number 1. A building has a calculated cooling load of 410 kilowatt. The dotted portion of the load is 100 kilowatt. This space is to be maintained at 25 C and 50% relative humidity. Outdoor air is at 38 C and 50% relative humidity, and 10% by mass of air supplied to this space is outdoor air. Air is to be supplied to the space at not less than 18 C. Assume a sea level pressure and find a minimum amount of air supplied to the space in cubic meter per second. B, the volume flow rates of the return air, exhaust air, and outdoor air. C, the condition and volume flow rates of air entering the cooling coil and the capacity apparatus dew point, bypass factor, and sensibility factor of the coil. Given is the cooling load 410 kilowatts, latent load is 100 kilowatt. Space condition 25 C dB and 50% RH. Outdoor condition is 38 C and 50% RH. And present by mass supplied to this space is outdoor air. Air is supplied at 18 C. Required A, the minimum amount of air supplied to this space in cubic meter per second. B, the volume flow rates of return air, exhaust air, and outdoor air. C, the condition and volume flow rates of the air entering the cooling coil. And D, the capacity, apparatus dew point, bypass factor, and SSF of the coil. Solution. So ito yung figure niya. 0, 3, 1, 1, 2, 3. Nayos ko lang ha. Q is equal to 410 kilowatts. QL is equal to 100 kilowatts. Ito yung procedure na sabi ko. Q sub S is equal to Q minus Q sub L is 410 kilowatts minus 100 kilowatts or 310 kilowatts. So chart 1B, from psychometric chart to chart 1B, andito sa, binigay ko sa inyo mga psychometric chart. So, normal temperature pressure. State 3, at state 3, yung room is 25C, P3 is equal to 50%, W3 is 0.0099 dito, H of P is 50.31 kJ per kilogram. Air, P sub P is equal to 0.85 mCm per kilogram air. Dry air at dry air. So, state 0, outdoor, start to HC and 50% of air. So, WO is equal to 0.0211 kilogram vapor per kilogram air. H sub O is equal to 92.3 kJ per kilogram. P sub O is equal to 0.911 kJ per kilogram. M sub O is equal to 0.1 ME2 is equal to 0.1 ME1. ME2. So, ito yung M sub O mo dito. So, figure. Okay. Tapos, M sub 1 mo is pumapasok doon, saka M sub 2, yan parehas. So, state 2, so state 1, so yung mga equation dito, ano na sa condition ninyo, hindi natin kailangan i-lecture po ulit ito. So, M sub AO over M sub A is equal to 0.1, M sub A1 over 0.A1 minus 0.1 MA2 is equal to 1 over 9. Kasi po yung pumasok doon sa ano mo, MA3 pumasok dito sa return air. So, siyempre, wala yung outdoor, pinawas na, exhaust na. So, there's H sub 1 is equal to M sub A sub O over A sub 3, H sub times H sub O plus H sub 3. So, divided by 1 plus M sub A sub O over M sub 3 is equal to 1 over 9 plus 92.3 plus 50.31 over 1 plus 1 over 9 is equal to 54.51 kJ per kilogram. Then W1 is equal to M sub A2 over M sub A3 times WO plus W3 is equal over 1 plus M sub AO over M sub A3 is equal to 1 over 9 times 0.0211 plus 0.0099 over 1 plus 1 over 9 is 0.01102 kilogram vapor, kilogram air. The psychometric chart ulit, so magiging 0.1 is 0.863 cubic meter per kilogram. Based dito sa dalawa, hanapin nyo ito, intersection niya. Ito na yun. So, T sub BB1 is equal to 26.3C and T sub WB1 is 15.1C. Then the relative humidity is 51.47. So, there, solve na. A is equal to accessible heat factor, which is QS over Q is equal to 310 over 410 is equal to 0.756. So, from chart 1B, TDB2, P2 is equal to 69.9%, H sub 2 is equal to 40.87, and W is 0.0090, and B sub 2 is 0.087. Hindi siya 18C, hindi siya ito, saturated. Kundi, based dito sa sensible heat factor, guguhin kayo ng chart ng line. Di ba may protector sa taas? So, yan. Ang tinamaan niya, dito, sa temperature na 18, tinamaan niya dyan, so ito lalabas. Okay? Therefore, MA sub 2 is equal to QS over CP D3 minus D2 is equal to 310 over 1.02. For 25 minus 18 is 43.4 kilogram per second. Then, the flow rate now at 2 is Q sub 2 is equal to MA2 times P sub A2 is 43.4 times 0.837 is 76.33 cubic meter per second. That is state 2. Ito na yung pumapasok doon sa room. Ayan, so provided by space. So, balik ka na. Ang lalagyan ko ng answer, kung ano yung tanong dito, yun ang lalagyan ko ng answer. So, pag ito linagyan ko ng answer, ito, so hindi naman yung required. So, that is, minus ko yun sa tama yung sagot. So, 0. Letter B. M sub A1 is equal to M sub A2 is 43.4. So, M sub A0 is equal to 0.1 times MA1 is equal to 0.1 times 43.4 is 4.34 kilogram per second. And also MA3 is equal to 9 times MA sub O is equal to 9 times 4.34 is 39.06 kilogram per second. So the return air is equal to Q sub 3 is equal to M sub A3 times P sub 3 is equal to 39.06 times 0.858 is 33.5 cubic meter per second. Answer. Exhaust air is equal to Q sub O is equal to M sub AO times P sub O is equal to 4.34 times 0.911 is 3.96 cubic meter per second. So this is the answer. The outer air is equal to the exhaust air. Q sub O is equal to 3.96 cubic meter per second. So nalalagay yung assignment ko doon. Aircon. So let us see condition of air entering the coil. So that one, ito yung mix mo, di ba? T sub dB1 is 26 PC, P sub WB1 19.19, P 51.27, P sub 1 is 0.863 cubic meter per kilogram. So this is the answer. Sa intersection ito, titignan mo, meron ka dito, di ba? Ayan. So ito na yung sagot mo. Awan. Okay mo lang. So volume flow rate is Q1 is equal to MA1 D1 is 27.45 cubic meter. So yan. Ito na yung equation pakagayahin nyo sinusukat niyo natin. So capacity is 592 kilowatt. Galing to 592. So, ito na yung capacity. Q sub C is equal to MA1 S1 minus S2 or 43.4 times 54.51 minus 40.87. And the answer is 598 kilowatt. The apparatus dew point graphical is T sub D 7.2C. Answer. And the bypass factor is T sub 2 minus T sub B over T sub 1 minus T sub D is 18 minus 7.2 over 26.3 minus 7.2 or 0.566. Now, the sensibility factor of coil is SSF sub C or Q sub CS over Q sub C. And where Q sub C is S is equal to MA1 CP 1 times T1 minus T2 as 43.4 times 1.02 times 26.3 minus 18 is 368 kilowatts. Now the sensibility factor of the coil is Q sub CS over QC is equal to 0.622. Now the answer. Okay, so next is the cooling tower. A cooling tower is a heat rejection device which rejects waste heat to the atmosphere to a lower temperature through the cooling of a water stream to a lower temperature. So cooling towers may be either use the evaporation of water to remove process heat and cool the working fluid to near the wet bulb air temperature, or in the case of closed circuit like tower, rely solely on air to cool the working fluid to nearby dry bulb temperature. So ito yung mga types of cooling tower. So cooling towers are designed and manufactured in several types. Atmospheric, the mechanical draft, which is the forced draft and induced draft, the hybrid draft, So, meron tayo ng mga type of airflow. We have the counter flow and the cross flow. Sa cross flow, meron double flow and single flow. And letter C is spray field flow. Type of construction, type by construction, field elected, factory elected. Field elected is on-site. Factory elected symbol pala, yun sa i-deliver sa inyo. Una. Type by shape, merong rectilinear, merong round, mechanical drop. Type by method of heat transfer, merong evaporative, B, dry tower, and the C, room abatement, D, water conservation type. So, dito lang tayo sa isa. Basic lang naman tayo dito. So, the atmospheric cooling tower utilizes no mechanical fan to create airflow to the tower. Its air is derived from the natural induction flow provided by the pressure spray. So, dito sa figure. Mechanical drop towers uses fans, one or more, to move large quantity of air to the tower. There are two different classes, the forced drop cooling tower and the induced drop cooling tower. The airflow in either class may be cross flow or counter flow with respect to the cooling water. Cross flow indicates that the air is horizontal in the filled portion of the tower, while the counter flow means the airflow is in the opposite direction of the cooling water. The counter flow tower occupies less floor space than a cross flow tower, but it is taller than for a given capacity. The principal advantages of cross flow tower are the low pressure drop in relation to its capacity and lower fan power requirement, leading to lower energy costs. All mechanical towers must be located so that the discharge air diffuser freely without recirculation to the tower, and so the air intakes are not restricted. Cooling towers should be located as near as possible to the refrigeration system they serve, but should never be located below them so as to allow condenser water to drain out of the system to the tower basin when the system is shut down. Mechanical drop. Forced drop. The forced drop tower shown in the picture has the fan, basin, and piping located within the tower structure. In this model, the fan is located at the base. There are no lowered exterior wall. Instead, the structural steel or wood framing is covered with paneling made of aluminum, galvanized steel, or absorbed cement board. During operation, the fan forces air at low velocity horizontally through the packing and then vertically against the downward flow of the water that occurs on the other side of the fan. The drip eliminators located at the top of the tower remove water drain in the air. Vibration and noise are minimal since the rotating equipment is built on a solid foundation. The fans handle most dry air, greatly reducing erosion and water condensation problem. Induced drop. Ito. The induced drop, sa taas yung ano mo, fan. Ito. Yung fan mo, andito sa baba. Andiyan sa baba siya, sa taas. So induced drop naman sa taas yung ano. The induced drop tower shown in the following picture has one or more fans located at the top of the tower that throw air upwards against the downward flow of water passing through the wooden rigging of backing. Since the airflow is counter to the water flow, the coldest water at the bottom is in contact with the driest air, while the warmest water at the top is in contact with the moist air, resulting in increased heat transfer efficiency. Hybrid drop. They are equipped with mechanical drop fans to augment flow. Consequently, they are also referred to as fan-assisted natural drop tower. The intent of their design is to minimize the horsepower required for the air movement, but to do so with the least possible stock cost impact. Properly designed, the fans may need to be operated only during periods of high ambient and peak loads. Characterization by airflow. Cooling towers may be by the relative flow are divided in several groups. We have the counterflow. So in the counterflow towers, the air moves vertically upward to the field, counter to the downward flow of the water. Because of the need for extended intake and discharge venom, the use of high-pressure spray system and the typically higher air pressure losses. Some of the smaller constructor towers are physically higher, require more pump head, and utilize more fan power than cross-flow counterparts. So the cross-flow tower have a field configuration to which the air flow horizontally across, yan, ganyan, across the downward flow of water. Water to be cooled is delivered to hot water inlet in the basin located atop to the field areas and is distributed to field by gravity through metering of orifices in the floor of the basin. So the cross-flow towers can be divided in double flow. In this kind of tower, the fan is inducting air to inlet and across two banks of field. Kabilaan to. Doon, meron doon sa kabila. Single flow, this kind of tower has only an inlet in one field bank. The remaining three sides of the tower be encased, so naka-enclosed. So single flow towers are customarily used in location where unrestricted air path to the tower is available from only one direction. Spray field. This kind of tower has not a heat transfer surface, depending only upon the water breakup afforded by the distribution to promote maximum water to air. So wala siyang spray lang siya, nag-cross lang yung water sa air. Spray field. Field erected, factory assembled. Ito naman yung two different kinds of cooling tower by construction. So yung the field erected cooling tower are those on which the primary construction activity takes place at the site of ultimate use. Separate sa spray field na. All large tower and many of the similar tower are prefabricated in piece market and shipped to the site for the cooling towers manufacturer usually provide financing. Factory assembled. The factory assembled cooling towers undergo virtual the complete assembly at their point of manufacture, whereupon there are shipped to the site in as a few sections as mode of transportation will permit. These are shipped.